Alright guys, sorry about this being such bad quality audio, but this is what we have because I am gone on Wednesday the 18th of September. Now I'm going to finish up this lecture 1.4 with this video. We already saw all of this, so I'm just going to keep on moving to the very next step. So if we're trying to find the domain of a function, you are trying to find the numbers that are possible for the independent values or x values of a function. So what you're trying to avoid is division by 0 or taking the even root of a negative number. So if we have an equation that looks like this, f of x equals 1 over x, we know that we cannot plug in 0 because 1 divided by 0 gives us no solution. So what we would say about this function is that x can't equal 0. Can it equal any other value? Sure. Plug in any other value and this equation 1 over x will work. Taking the even root of a negative, let's say that we have the square root of x, f of x equals that. Now let's say that we plug in for x -2. Can we do that? No, that's no solution. So we know that x cannot be negative, and how we would write that is that x has to be at least equal to 0 or more than 0. To find the domain of a function, this first is just a set of points, but the domain are the x values. So we've got -3, -1, 0, 2, and 4. That is the domain. The domain of the second one. Now, what we're saying is that the bottom can't equal 0. What number would make this bottom 0? Well, -5. Other than that, it's all going to work. So we're going to say that the domain is all real numbers except x cannot equal -5, because if we plug in -5 right there, it'll turn the bottom to 0, and that is no good. The domain of for the volume of a sphere. This is where we have to think geometry here. Now we have the volume is equal to 4/3 times pi times the radius squared. Now if we're thinking geometrically, are we ever going to have a negative radius? No, we aren't. Radius is always going to be just the distance is going to be positive. To have a sphere, we have to have a radius, because if we have a radius of 0, we don't even have a sphere. Nothing exists. So we know that the radius has to be greater than 0. That's it. And then last, for part D, we know that what's underneath has to be at least equal to 0 or greater than 0. That cannot be, it cannot be negative. So what you do is you set whatever is underneath, saying that it's equal to 0 or greater than 0, and then we're going to solve for x, solve the inequality. Well, if I move the -3x over, it becomes positive 3x. Divide by 3. I get x is less than or equal to 4/3. So that would be the domain. Finding the domain of these functions. Oops. Part A. What we have to do is just make sure that the bottom does not equal 0. So let's figure out which values would make it equal to 0. Set the bottom equal to 0, and whatever we solve for, those values are going to be the ones that don't work. So factor out an x, you'll be left with x minus 2. Set each of these factors equal to 0. You get x equals 0, and x minus 2 equals 0, and solve that, you get x equals 2. Now, these are the values that would make this bottom 0. So, and since that's not allowed, we will say that those are the values that x cannot be, because then the function won't work. For the next one, I'm pausing for a second just because I want to make sure this is right. And you say, okay, is there any value that you cannot plug in for x? Does this have any restrictions? Is it under a square root or under a root of any sort? Is there any fraction in this? No. So the x, or the domain, will be all real numbers. And lastly, since this is an even root, meaning the root is 4, it's an even number, we can't take the negative, or the even root of a negative number. So what's underneath has to be equal to 0 or greater than 0. Solve that. You get x is greater than or equal to negative 6. Now this is the weird part. A piecewise function is a function defined by 2 or more equations over a specified domain. So it's like you're going to have one part of one equation, and it's going to stop, and then the next equation is going to take over at some value of x. When graphing, graph each equation separately over their specific domains, and then watch beginning and ending points. Let's see. So they gave us the function. This is what we're going to be worrying about right here. And they give it to us again down here. Wait a second. Did I screw up? Oh, I'm sorry. Okay, so the first part is just evaluate. I was looking for the graphs. So evaluate the function when x equals -1, 0, and 1. So we are going to do f of -1. Now, you ask yourself, okay, which one of these two equations do I have to plug it into? And you say, well, -1 falls into the domain x is less than 0, because -1 is less than 0. So that means I have to use that equation. So I'm going to plug in -1 into x squared plus 1. And -1 squared is 1, plus 1 is 2. So you would say f of -1 equals 2. All right, so then we're going to say that we have to evaluate f of 0. That's the next one. Now, when x is equal to 0 or greater than 0, we're using this function. So you say, all right, x minus 1, that's 0 minus 1, equals -1. So your f of 0 equals -1. And then lastly, we want to check f of 1. And once again, when your x value is greater than or equal to 0, use x minus 1. So in place of x, I have 1 minus 1 equals 0. So your f of 1 equals 0. If that's a little fast, make sure that you pause this. Going on. We want to evaluate the function when x equals 0, 3, and 5. Alright, so let's test 0. We're using our h function. H of 0. And you say 0 falls into the domain x is less than 2. So we're going to use that function. In place of x, we use 0 squared plus 3 equals 3. So h of 0 equals 3. The next value of x is 3. You say, okay, 3 falls between 2 and 4. So 7, what does that mean? Well, it just means that no matter what value you put in for x, you're not really having to put it in x. It just tells you what the answer is, 7. And what that really means is that's a horizontal line at y equals 7 between this domain and this domain. And we'll get to that when we actually start graphing these in the next couple problems. So you can say that the h of 3 equals 7. And then lastly, we have to find the value when x equals 5. So we'll call that h of 5. 5 is greater than 4, so you're plugging it in there. 2 times 5 minus 1 equals 9. So your h of 5 equals 9. Now we're going to get to the graphing. So we're going to have the first part, x squared plus 1, for x values that are less than 0. Now, some of you guys might have to do an xy chart. That's totally fine. So for x squared plus 1, do your xy chart. And traditionally, we would start at like -3 and go to +3, or go to from -2 to +2. I'm going to start at -3. -3 squared is 9 plus 1 is 10. Then I'm going to go to -2. -2 squared is 4 plus 1 is 5. -1 squared is 1 plus 1 is 2. And then 0 squared plus 1 is 1. Okay? Now, I could keep on going to 1, 2, 3, 4, and so forth, but it tells me that I only want to plot x values that are less than 0. Then you might be saying, okay, well, Duff, you included 0. Why did you include 0? Well, that is because that by using this point as an open circle, it's going to show that it would go to that point if we were to plot it. But instead, we need all the points to the left of that. So if I plot -3, 10, let's see if I have that, 3, 3, 6, 9, 10. And then -2, 5. -1, 2. And then 0, 1, because it's not equal to 0, right here, at this point, you're leaving this as an open circle. And you're only plotting the points where x is less than 0. Then you come over to the other equation right here. Maybe I should use black instead, because that's already red. And you say, okay, I want to plot the points for this one where x is greater than or equal to 0. So this time, when we're making our xy chart, we're actually going to start at 0. And it's going to be filled in. 0 minus 1 is -1. 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2, and so forth. And you want to fill that in. So it's 0, negative 1, filled in. 1, 0, 2, 1, 3, 2, and so forth along that line. So we are only plotting part of each of these functions. At 0, that's where it switches over. And for the bottom function in black, you actually fill in 0 because there's an equal sign right there. For the top one in blue, you do not fill in at x equals 0 because it doesn't have an equal sign underneath there. Stop this if you need it to start writing this down. Okay, so let's do the same thing. We're using this function for x values that are less than 1. So x values that are less than 1 would be like this. Less than 1 if we're doing the number line. And then for x values that are equal to or greater than 1 might look like this if you're doing this on a number line. So we know that on the black one, just like the previous one, we're going to fill in at negative 1. And for the blue function, it's going to be open circle. Let me erase this because those aren't actually right. Okay, so let me do an XY chart for 2x plus 1. So x values that are less than 1, let's pick some, maybe negative 3, negative 2, negative 1, 0. And then I'm going to include 1, but it's going to be open. Negative 3, if I plug it in for 2x plus 1, 2 times negative 3 is negative 6, plus 1 is negative 5. 2 times negative 2 is negative 4, plus 1 is negative 3. 2 times negative 1 is negative 2, plus 1 is negative 1. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus 1 is 3, and that's open. For the other function, negative 1/2 x minus 3, and that's for x values that are equal to or greater than 1. So I'm going to start at 1, 2, 3, 4, and so forth. Say 1/2 times 1, or negative 1/2 times 1, is negative 1/2, minus 3 is negative 3.5, or negative 3.5. And that's actually going to be filled in, because it is equal to 1. Negative 1/2 times 2 is negative 1, minus 3 is negative 4. Negative 1/2 times 3 is negative 1.5, minus 3 is negative 4.5. And 4, negative 1/2 times 4 is negative 2, minus 3 is negative 5. Now it's time to graph. Let's do the blue function first. So at negative 3 I have 5, negative 3, 5. Why is that blue? It needs to be blue right there. Negative 2, 3. Negative 1, 1. 0, 1. What am I doing here, people? I am really tired. I should have gone to bed earlier, but you're probably thinking, oh my God, Duff, what is going on with you? That's what's going on. Negative 3, negative 5 is down here. Negative 2, negative 3 is right here. Negative 1, negative 1. 0, 1. And then 1, 3. But that's open. It's all to the left. For the black function, 1 goes at negative 3.5. So 1, negative 3.5. Fill it in. 2, negative 4. 3, negative 4.5. 4, negative 5, and you see how that goes. sorry. Skipping ahead. Too much. Go back and you got it. Okay, going on. Don't know what's going on with that. Let me move it back down. Okay. Now we have three pieces to the function. First one, negative 2x plus 5 for x values that are less than 2. Negative 1 times negative 2 is 2, plus 5 is 7. 0 times negative 2 is 0, plus 5 is 5. 1 times negative 2 is negative 2, plus 5 is 3. 2 times negative 2 is negative 4, plus 5 is 1. And this is going to be an open circle. Let me go ahead and graph that right away. 2, 1. Open circle, 1, 3. Good. Okay, let's do the next one. For values between 2 and 4, and equal to that is negative 1. So what's that saying is that if you start at 2, it's going to be equal to 2, so it's going to be filled in. Then go to 3 and go to 4. Either way, your value is still going to be negative 1 at all those points. So let me go to 2, go to negative 1, fill it in, 3, negative 1, 4, negative 1. It's a horizontal line. We've seen that before. And the last part, I'm actually going to do this in red. I'm running out of, well, I guess I could change that to purple. Okay, let's see if that works. Purple, 1/2 x plus 3 for x values that are greater than 6. I said minus 3, I should have said. X, Y, values that are greater than 6. Okay, so I'm going to start at 6, but I'm going to leave it open. 1/2 times 6 is 3, minus 3 is 0. That's my open dot. Then I'm going to go up. 7. 1/2 times 7 is 3.5, minus 3 is 0.5. And then 8. 1/2 times 8 is 4, minus 3 is 1. And so forth. So at 6, I'm going to go to 0, but it's open. 7 is 0.5. 8 is 1. And it's going to follow that because it has a slope of 1/2. 3 different parts, totally discontinuous. And you see in this area, we don't have any values that cover the x values between 4 and 6. Well, that's all right. That's what the piecewise called for. Please do your homework. This is your homework. It's not too bad, but please do those piecewise functions because they are hard. We'll practice them together when I get back, probably Thursday and Friday. We'll do a couple of each day. That is it. That's the end of my video. And how long is that? 24 minutes. Oh my God.